In this problem, we're going to build on some of the JavaScript lesson we did in the previous one, and we're going to handle identifiers, numbers, and strings. Real quick, let's ask ourselves, what are the difference between those? So we have an identifier, and as we talked about in the lecture, identifier is a name for something, usually a function or a variable. We then have numbers, and we're going to be able to handle numbers such as -1, 2 dot, 3.5, etc. Then we have strings. This string contains the word blah, an escaped quote, so the string contains this double quote, blah, question mark. I don't know if you heard my raised pitch at the end, blah, and then another double quote. And it ends, we indicate the end of the string with unescaped double quotes. So we want to write regular expressions to match these things, because that's how we're going to write the functions that tell the Lexer how to tokenize it. So let's do the identifier first. This one's pretty straightforward. We need at least one letter, and it can't be an underscore, but the casing doesn't matter. And after that, it can be as long as we want, and it can have as many underscores as we want, and then letters as well, where the casing doesn't matter. So that's our regular expression for the identifier. For the number, we're going to have to be a little trickier. Let's say we have this number, -542 and 555. So we're going to write a regular expression to match this, as well as all the other numbers, but this has all the pieces that we need to consider in a regular expression. So the first thing is the minus sign. The minus sign can only occur at the beginning, and it's also optional. We then can match at least one, but possibly more, numbers up into a decimal point if it exists, but it could also just end there, such as the -1 we have here. So the numbers 0 through 9, and it has to be one or more of them. This goes there, this matches that part. Now we're going to have a chunk that's optional. If we go down this route, we have to have a period. We have to escape the period because it has meaning in a regular expression. But after the period, we can only have numbers, and there can be 0 or more of them. 0 for the case where you just ended a period, which is often denoted to mean you want a floating point. But in this case, we're going to treat everything as a floating point. And then a star. So that's a regular expression. To go back, the dot goes here. These 5s go there. So now we just want to do strings. So we have a regular expression. The first thing and the last thing we have to match are going to be the double quotes. And I used a single quote because I don't have to escape the double quotes in this, and that makes it nice. In between the double quotes, we can have 0 or more characters inside of them. And those characters can be in two groups. It's either escaped, like we have here, or it's just a character by itself, all the other letters. So let's do the not escape first. So that's going to be anything that's not a double quote or a backslash. And we have to escape the backslash if we want to match that. So anything but those. So that's going to be everything here, all of this, but not these quotes right here because there's a backslash or a quote there. If we get any one of those, we're going to match a different rule where we have to have a backslash, but after that backslash, we can have any character, and that's what the period means. And I forgot to put my question mark. There we go. So that's the regular expression we're going to use. As you can see, as these regular expressions get more complicated, doing more complex things, they get messy. Messy very, very quickly. Sometimes it's really convenient to write a regular expression like this. Sometimes you might just write a bit of code to do the same thing. But in this case, regular expressions are super powerful and super fun, and that's what we're doing here. And so here I have my solution. I'm going to have 3 types of tokens, the identifier, the number, and the string, which we went over. I have the identifier, which is exactly the regular expression we came up with. And all we do is identify that type. For the number, when it matches, we're going to call float, which converts the string value that is in the token when we get it to an actual floating point number. And then for the string case, we're going to strip off the quotes and just get the contents of the string itself. So that's what matters to us. Ignore white space, have to deal with new lines and the errors as well.